In this series of videos, we're going to explore and talk about how we solve trigonometric equations using various different methods. Now, in previous videos, we were verifying an identity and dealing with identities, which remember are different from equations. An identity says that if I have something, if it's an identity, then I can replace it with what that identity is equal to. Okay? An equation is something is satisfied by only numbers, by some numbers but not others. In other words, there's only one value for x in this equation that satisfies the left and the right. So in this section we are talking about solving, whereas previously we were verifying that we had identities. Now, when we talk about solving these trig equations, there's going to be all sorts of various methods we can do that, solve them by, and the first ones we're going to talk about are solving by linear methods. Now, you're pretty familiar with this because it's what you've been doing to solve algebra equations for a long time. We would isolate the variable, use the properties of algebra to solve, in other words, the addition, subtraction, or maybe we would divide off a coefficient. Once we get our trig term, which is the variable, isolated, we would determine which quadrant my angle or the solution is going to fall in, and then we use the inverse in order to solve the angle. So we're going to look at this first set of examples, and for them I'm looking at solutions that fall between 0 and 360 degrees. So I'm doing degree measurements here. So this first example says that I want to solve the equation 2 cotangent x plus 1 is negative 1. Now, cotangent x is the term or the variable that I'm trying to isolate. In order to get that by itself, we use our algebra properties, which say I'm going to subtract 1 from both sides. That gives me 2 cotangent x is negative 2. Again, I'm trying to get cotangent x by itself, so I'm going to divide both sides now by 2. And I find out that cotangent of x is negative 1. Once I have it to this point right here, I am going to do a couple of things. I want to first determine what quadrant is my solution going to lie in. If the cotangent of some angle returns a negative value, then I have to be talking about angles for cotangent up here in quadrant 2 and also in quadrant 4, because cotangent is negative in those areas. And then I want to determine for what angle, when I take the cotangent of it, gives me back a negative 1. So if you remember, if you remember your reference angles, that would be at 45 degrees. 45 degrees. The cotangent of 45 gives me positive 1. And since I'm looking for angles that are occurring here in quadrants 2 and 4, I must be looking for this angle over here, which would be at 135, and this angle down here, which would be at 315. So the answer to this, the solution, would be 135 degrees, as well as 315. Okay, that's the solution on the interval between 0 and 360. So let's practice another one. For this example, I have 2 secant x plus 1 equals secant x plus 3. I'm wanting to isolate the trig function. In other words, that's what I'm solving for initially, and I'm going to do that by gathering all of my secant x terms up on the same side. So I'm going to subtract secant x from here and subtract secant x from the right, and from the left, and I get secant x is plus 1 equals 3. And now, since I want this secant x by itself, I'm going to subtract 1 from both sides, and I get secant x is equal to 2. So now I want to determine, again, which quadrant, when I take the secant of it, I get back a positive value. So secant is positive in both quadrants 1 and 4. And for what angle, when I take the secant of it, do I get back a positive 2? That's going to occur at 60 and 300. Okay, so you have to remember our trig values as we're moving around the unit circle. let's try two more examples, only this time we're going to do them in returning radian values, or we're going to solve them on the interval between 0 and 2 pi. So again, for this first example, we are trying to get sine x by itself. So I'm going to subtract 3 from both sides, and I have 2 sine x is equal to 1. Then I divide both sides by 2, and I find out that sine x is equal to 1/2. So what quadrant am I looking at for possible solutions here? Well, sine is positive in quadrants 1 and 2, so when I take the sine of pi over 6, I get a positive 1/2. And again, over in quadrant 2, that would be at 5 pi over 6. So there's the solution. Just this time, I am on the interval between 0 and 2 pi. So pay attention to how you're supposed to give the solutions when you're working these. And finally, we have this equation here. Let me change that. Okay, so the equation should read tan squared x plus 3, and I am trying to get tan x by itself. So I'm going to subtract 3 to the right-hand side, and I find out that tan squared x is equal to -3. But in order to solve for this, I would need to take the square root of both sides. Now, I cannot take the square root of -3 and get back a real answer, so actually the solution to this is no solution, since I can't take the square root of a negative number. And that's one method of solving our trig equations.